Corporate finance practice problem using OneNote. Standard deviation, variance, and coefficient of variation calculations. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side down in the 1312 Standard Deviation, Variance, and Coefficient of Variation tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our presentations up top will be mirrored down in the text area. Same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we have our information up top going through the calculations on down below. In the prior presentation, we took a look at some standard statistical kind of concepts. Now we're going to look at those statistical concepts as a tool, typically for projections that we're going to be making out into the future. So there's multiple different scenarios where you can think about this kind of analysis coming into place. We're going to start off with an advertising campaign here. And what we want to do is group what we think is going to happen into the future into some components, because when we start to think about the future, what might happen from something like an advertising campaign and try to make projections about it, it can be very daunting to try to predict what's going to happen into the future. One way we might do this is to say, let's group the categories in likelihood of something like low, average, high, and very high, 4 basic categories, and then say what the standard, in this case, unit sales would be basically within those categories. So we're going to say, okay, if the advertising based on past experience, and obviously a lot of this information is projections out into the future, therefore we're going to look at the past experience as best we can and just do the best we can to kind of format and structure the data in such a way that we can wrap our mind around it and make as good a projection into the future as possible. So we're going to assume or look into and then get these 650, that if the advertising campaign is low, that's going to be our low results. Now, again, we might take past data and we might basically project then into the future, taking into consideration the current economy as well. Then we'll take average. If it's an average campaign, 750 units, high, 900, very high, we're going to be 1,000. So these are the markers at which we would determine if something, is low, average, high, or very high. So then we want to assign probabilities, or how likely we think that these outcomes will happen. Again, these probabilities are based on past experience, and they're going to have to be estimates because we're making probabilities and guesses about what's going to happen into the future. But this is one way that we could structure this thought process in our mind so that we could get to, in essence, an expected value, which we'll often need in order to do further assessments and further kind of calculations with regards to whatever we're talking about. In this case, an advertising campaign, the unit sales then possibly being necessary for calculating how much inventory we need and that kind of stuff. So we take then the unit sales and we're going to multiply it times the 20%. Now these percentages, 20, 20, 30, 30, would be based on past experience and whatnot. They have to add up then, of course, to 100% so that we can then apply our percentages. So then we'll just simply take the 650 times the 20%. So let's just do one of them. 650 times the 0.2, 20% is the 130. The 750 times the 20%, 150. 900 times the 30%, 270. And then the 1,000 times the 30% is the 300. So now note that we hit these markers as to when something would be low, high, average, very high, applied the percentages, and this then is going to be what we will call our expected value. This is the one we're basically would be using if we were then to kind of think forward and try to do projections on what our inventory needs to be and whatnot. As in this case, we're talking about an advertising campaign, the number of units that we might have to sell with. So then we come up to that. Now you can think of that as the expected value, which is basically kind of the average or the mean when you think about our statistical type of terms. So then we're going to do our same calculation with our population variance as we saw with the statistical analysis. There's going to be a faster way to do this when you see this standard setup. Note that oftentimes many problems might simply be asking you for this expected value. You might use this oftentimes to come up or structure your mind around some set of information that you're projecting out into the future to get to the expected value, which you can then use for further analysis. For example, this might be further used once again for the calculation of inventory and how much manufacturing you might need or something like that. But we might have multiple sets of data that we're combining together, and we might want more statistical analysis other than this, which is basically the average, which would give us kind of the variance around the average. And so we'll take a look at those items, and we'll do it with just one problem at a time right now, and then we'll do some comparisons, which will make these calculations a little bit more clear. So first, we're going to break this information out into kind of a list so it looks more like the list that we would basically be working with these statistical type of analysis. And then we'll break it out in the format that will more commonly be used for these types of problems down below where we would use these weightings. But first, let's break out this list, because I think this is one way to link the math to the concepts that we're talking about here. Let's pretend we're going to break this out into a list of data, and let's make out 10 items that have this structure of 20%, 20%, 30%, 30%. So if we have 10 items and we said 650 was 20%, then we're going to have 2 of them being the 650s, the 2 items out of 10, 20. And then we're going to say that the 750, once again, 2 of them at the 750, the 900 at the 30%. So we'll have 3 900s in our series of 10 data sets, and then 3 1000s at the 30%. So now we have a list of data that basically represents our formulas up top, or our information up top, with the populations represented in percents. And then we can apply our formula the same format we did here. So we had each unit minus the mean. So now we'll calculate the mean here, and then we'll subtract that out. So it'll look like this. And the mean we already calculated with that 650 at the expected value. But if you see it in a list formula like this, how would you calculate the mean? Well, it would be 650 plus 650 plus 750 plus 750 plus 900 plus 900 plus 900 plus 1,000 plus 1,000 plus 1,000 divided by the number of units, or the population, which in this case was 10. There's 10 items here, divided by 10, and that would give us our 850. So that 850 then is the average, or the mean, kind of like the center point that we're talking about, not the median, but the mean. And then we're looking at the difference between the value and the mean. So the 650 minus the 850 is the negative 200. 650 minus 850, same. 750 minus the 850, negative 100, same here. 900 minus the 850 is 50, same, same, same. 1,000 minus the 850 is 150. So then that we're going to square it. So now we're on this part of our formula, squaring each of the items. So if I was to square each item, and let's just do one of them with the trusty calculator, that will make the positive numbers the negative numbers positive, and it will amplify the results. And so we're going to say, let's say this is 200 negative, and square it. There's the 40,000. So 40,000 there. Pulling this back over, and if we squared all of them, we're going to do the same. 40 there, 1,000, 10,000 there. Negative 100 squared, 10,000, 50 squared, 2,500, 50 squared, 2,500, 150 squared, 22,500, and so on. So, and then we can sum these up. So if we sum these up, this 175,000, that's the numerator up top. Then we're going to divide it by the number of units, or the population, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. So we'll take that and we'll divide it by the population size 10. That's going to give us our 17,500. That is the variance that we talked about in a prior presentation. Now notice it's in unit squares. So if we're talking about the units, we're talking units squared here. So oftentimes you would want to take the variance and take the square root, and that's what we call the standard deviation. So the standard deviation then is going to be in the units that we're talking about of the 132. So if I take then the square root, the 17500, and then square root, we get the 132.29 about. So there is that. And that's going to be in the actual unit. So that gives us an idea about, and that's in, in this case, units, which were the units of sales that we're going to have for our advertising campaign. And so that'll give us an idea about the disbursement around the mean and units that are typically relevant to us. And then this last piece will not usually be relevant unless we have different things that we will be comparing, which we will do in the future, like 2 advertising campaigns that we were trying to compare. So that would then be the 132.29 divided by the 850, which would be about 0.1556. You could represent this as a percent or decimal. That would be the coefficient of variation. So again, if I had 2 advertising campaigns and we had different values for the units, but we want to then see how similar they are with regards to their disbursement around the mean, which could give us a level of risk, which we'll talk about in the future, then that will be a relevant number. And that's a really common kind of calculation in a lot of these types of calculations will be this coefficient of variation. We'll practice just calculating it a couple times, and then we'll get into the comparisons in future practice problems. Now, you could do this in Excel. If you did this in Excel and just put your little table down here and represent this in a table format, you could take the mean or average. That would be the average of our data set, which would be up top of these numbers. Average of those numbers, that would be the mean or the average, which is also the expected value that we're talking about here, 850. The standard deviation would be equal to the STEV.P, and the dot P could be an S2 if it was a sample. We're typically using the population here. If you want more information on statistical differences between population and sample, a lot of information out there on those just purely mathematical concepts. So you can search around on your favorite browser or YouTube and whatnot to check those out, but that would give us our 132.29 matches here. And then we have the variance, which we can calculate at the VAR.P. Once again, P population versus S, which would be sample. We're using population here, which would be the 17.5. And then the coefficient of variation, same calculation, standard deviation divided by the mean or average or expected value. And that'll give us the 0.1556. So that's one way I think it's useful to kind of bridge into the way it will normally be presented here. Same calculation with our expected values up top. And now let's basically think about it the way we would often format these types of problems. So if I took the 650, for example, times 20%, we get the 130. If we took the 750 times the 20%, we get the 150. If we take the 900 times the 30%, we get the 270. The 1,000 times the 30%, the 300. There's our 850 again, which, as we saw, is basically the mean or the average. So we got a bunch of different words for that one. It's a well-known concept, and it's got many titles, many names. Average, mean, expected value. It's lived a long time, and it's got a lot of history and a lot of different names. Okay, so then we're going to go down here and figure it this way. Let's put our possibilities, the 650, the 750, the 900, and the 1,000, just listing out our possibilities. We're in essence doing the same kind of concept or calculation. Sorry to bounce around here of this population variance formula, but it's a little bit different format because we're going to apply the probabilities last, basically. So you'll see the similarities. So the expected amount is now the 850, which is basically, once again, the average or the mean in essence. And then if we take the difference between these, now we got the 650 minus the 850 is negative 200, the 750 minus the 850 negative 100, 900 minus 850, 50, and the 1,000 minus the 850 is the 150. Then we're going to square these items. So the 200 squared, so let's do one of those in the calculator, just for the fun of it, because it is good times. The 200, making it negative squared 40,000. Wow, that was fun. That was fun. I wouldn't want to do another one, but no, I won't. So we got the 100 negative squared is the 10,000. The 50 squared is the 2,500. The 150 squared, 22.5. Then we're going to apply the probabilities, which is going to be the 20, 20, 30, 30. So 20, 20, 30, 30. And that then gives us our end result of the 40,000 times the 20%, the 8,000, the 10,000 times the 20%, 2,000. 2,500 times 30%, 750, and the 22.5 times the 30% of the 6,750. And if we add those up, population variance of the 17.5, which is the same result we got up top. So this is more the standard way that you will see these, although a little bit different of the calculation, as you can see, than just a series of numbers, which we're probably most used to when we're dealing with a series of numbers possibly. Or that's probably what you remember most when you're looking back on statistics. So it's a series of numbers. So then we have the standard deviation, which is going to be the 132, in essence taking the square root. So let's do that. And so let's say we're going to take the square root of 17500 and square root. So the root squared is about 132. It's been rounded. And then And so that's going to give us the same kind of concept we talked about before of the variance around, the average or the mean. And then we got the expected value of the 150, basically the average or the mean. The 132 minus the 850 is rounded, 132 being rounded, is going to give us that coefficient of variation. Not really helpful for us when we only have one project here, but when we have multiple projects, it can give us an idea about the spread around the mean of multiple projects, once again, when having different basically outcomes or dollar amounts, but similar, or we want to see how similar, the spread is around the average or the mean or the expected value.